Hello everyone, this is DIY assignment 2 of IITKGP. My name is Devraj Adhikary and from section 20, and my roll number is 20NA10015. So in this assignment, let first give me the idea of the assignment. In this assignment, I have tried to make a social distancing alert system using the Arduino and the ultrasonic sensor. It will help people maintaining the social distancing properly. So how this assignment helps in the COVID situation? This project has LEDs and a piezo buzzer. Once anyone approaches the user, the LED starts blinking, and after all the LEDs blown up, the buzzer sounds and alerts the user about the issue. Thus in workplace or in streets or in any situation, this project helps the user to maintain social distance properly and stops the spread of coronavirus. So let us understand the circuit. At first we will introduce the components that we have used in this circuit. So I have used the Arduino Uno R3, which you can see in the first picture. I have used the NeoPixel Ring 12 as LEDs, which you can see in the second picture. Actually this thing is the NeoPixel Ring 12. And I have also used the ultrasonic distance sensor, that is shown in the picture 3. And finally I have used a piezo buzzer, which you can see in the picture 4. Understand how the circuit works, but before that let us see the simulation of the circuit. So here I will start the simulation, and this is the user, means this is the person, and the user will use this circuit, and here is the ultrasonic sensor. This is the NeoPixel Ring 12 and this is the piezo buzzer. So let us see how this works. Here it is the person is at a safe distance from the user, so that's why no LEDs are blinking. Let us see if we change the distance, how the LEDs are working. So we are changing, but it is not showing because it takes some time. So here you can see the 3 LEDs are blinking, 3 green LEDs. Now we will decrease the distance, and you can see as we are decreasing, the green LEDs are blinking. We are decreasing 2 green LEDs. We are still decreasing 3 green LEDs. Now the first yellow LED is now blinking. I am decreasing more yellow LEDs. Now all the yellow LEDs are blinking. Now here we'll start the red LEDs. First red LED, second, third, and as soon as the fourth red LED blinks, the piezo buzzer will start sounding, because that is the alert system. I am decreasing. Here we go. Here is the sound. By hearing this sound, the user who is using the circuit can understand that the other person is not at a safe distance, it is at a critical distance. So now we will stop the simulation. We will understand how the circuit works. For that I have here copied the text code, and we will understand it. So here you can see that I have used an Adafruit neopixel.h, that is a header file. Actually it is a library which is initialized with the lead pin 3 and the net number 12, because there are the 12 LEDs in the NeoPixel Ring 12, and it is also available in the 16 and 24 number. You can modify it. So as soon as the Arduino board is powered up, the ultrasonic sensor starts measuring the distance of the person. And here you can see the range of the distance is, maximum distance is 300 meter and the minimum distance is 100 meter, as we move from the safe to critical distance. So in the ultrasonic sensor there are 2 pins which are using. The trigger pin is connected to the digital pin 5 of the Arduino board, and the echo pin is connected to the digital pin 6 in the Arduino board. And here in the circuit, the digital output of the piezo buzzer is connected to the digital pin 2 of the Arduino board. The distance measured by the ultrasonic sensor is mapped to the number of LEDs glowing from 0 to 11, which is actually counted with a set of 4 LEDs, which means the set of 4 LEDs will glow according to the measured distance and controlled by the Arduino board. So here you can see it is the function the calc distance, which measure the distance in the ultrasonic sensor by the help of the ultrasonic sensor. This calc distance is the function which measures the distance, and here I can show you how the piezo buzzer works. So I have introduced an integer that is let to glow, and it is measured by the distance measured by the ultrasonic sensor of that time, the minimum distance, maximum distance, and the particular LED number. And if this number is equal to 12, then our buzzer pin will go to the high state and the buzzer will sound. And in any other case, the buzzer will not sound and only the LEDs will glow. So now here is another function that is called the strip.color. So strip.color is the function to give the intensity to that particular LED. In the first case, we have set the intensity of the green light to the 50. That's why the first 4 LEDs are blinking in green light. You can change this intensity according to your own measure. You can change it to any number between 0 to 255. In the second set of 4 LEDs, that is 4 to 8, we have given the green color also 50 intensity and the red color also 50 intensity. That's why it is its color is finally yellow. And in the third set of 4 LEDs, that is 8 to 12, we have only given the red color to the 50 intensity. That's why the last 4 set of LEDs are blinking in red color. So if the that is we have here we have introduced a loop that is basically to blink up the LEDs. If the distance is at a safe distance, that is greater than 300, only one LED will blink, that is the green LED. And here in the coloring system of the LEDs, we have used a basic RGB coloring system. So thus this system, this is the code, thus this system provides the audio visual alert for the social distancing. Now what we will do, we will compile this code in the Arduino IDE. So here is my text code and I will copy it at first. Let us copy it. And here in the Arduino IDE, we'll paste it and we'll see if this is compiled. Here is an important thing to say that the adafruit neopixel.h, this the library, is usually not installed in the Arduino IDE. You have to download it separately from the browser. I am showing you. This is the zip file of that library I have downloaded from the browser, and here is an option through which we can add this library in the zip format. I have added it already, so there will be no problem in compiling. Let us see. So first we have to save that. After that we will compile it. The compiling is in process. The compiling is important because if the code does not compile perfectly, we cannot use in the physical circuit or the physical system. If it compiles perfectly, then we can use the code. Let us wait till the compiling is done. If any error occurs in the code, that will be shown in here in this black part. Otherwise it will show something else. The compiling takes a few time. So here it is showing no error. It is showing some message that is compiling is done. So we can use this code perfectly in the physical system, and you can also understand that our circuit is perfectly fine and we can use it. So thank you everyone for listening to me. It was this week's assignment. If you like my video, please like and share it. Thank you.